A very good morning, students. In the last video, we have discussed the linear differential equation. Today, we are going to discuss another topic, that is equation reducible to linear form, that is Bernoulli's form. Okay, I hope you are all understood the differential means linear differential equations, right? Okay, the linear differential equation is of the form dy by dx plus py is equal to q. Okay, where p and q are the functions of x or some constants. So we find out the solution for this linear differential equation. First we should find out the integral factor. So to find out the integral factor is equal to e to the power of integration of p into dx. So after finding the integral factor, we have to find out the general solution for that. Y into integral factor is equal to q into integral factor dx some integral constant, right? This is regarding the linear differential equation. So next we move on to the second topic, that is equation reducible to linear differential equation form, that is Bernoulli's form. Okay, so Bernoulli's form. This is Bernoulli's form. The standard form of the Bernoulli's form is dy by dx plus py is equal to q into y to the power of n. Okay, so what is Bernoulli's form? Certain equations of first order which are not linear can be reduced to linear form, and hence by changing variable by with suitable substitution, that's the method is called as the Bernoulli's equation. Okay, that's okay. The general equation of the Bernoulli's form is dy by dx plus py is equal to q into y to the power of n, where q and p and q are the functions of x or some constants. So this can be reducible to in a linear form. How? By dividing the whole equation by this y to the power of n, means that q coefficient y to the power of n. So if I divide the whole equation by y to the power of n, what I'll get? 1 divided by y to the power of n plus py by y to the power of n is equal to q I'll get, right? 1 divided by y to the power of n can be written as y to the power of minus n dy by dx plus y by y to the power of n. If I take this y to the power of n to numerator, it will come y to the power of minus n, right? Here the 1 is there. If it comes to denominator part to numerator part, you will get y to the power of minus n. 1, the bases are same, we can add the powers. So you will get y to the power of 1 minus n is equal to q, right? So after dividing that, we will get the equation. We call this as equation 2. The first equation is 1. This is 1 and this is 2. Now I am going to take the substitution. I'll take this p coefficient. The p coefficient is y to the power of 1 minus n as q. Then I differentiate it with respect to x. We know the differentiation, right? X to the power of n differentiation is n into x to the power of n minus 1, right? So here y to the power of 1 minus n differentiation is 1 minus 1 y to the power of 1 minus n minus 1. So plus 1 minus 1 get cancelled, we will get y to the power of minus 1 dy by dx. We are differentiating with respect to x, means here we will get dy by dx. This is equal to dv by dx. Okay, so I want this y to the power of minus n dy by dx. I'll taking this minus 1, sorry 1 minus n to this side. So I'll get 1 divided by. Okay, by using this equation, the equation 2 becomes, you see, y to the power of minus n dy by dx. Here we have, in place of this, we can write this as 1 divided by 1 minus n dv by dx, right? So the equation 2 becomes, in place of y to the power of minus n, I am substituting this value 1 by n dv by dx plus pv is equal to q. Y to the power of minus n is there. So in place of that, here we have taken y as v, right? Y to the power of minus n as v. So it becomes v is equal to q, right? I don't want any coefficient for dv by dx because in a linear in a standard linear differential equation we don't have any coefficient for dy by dx. In that y is a dependent variable. In this v is a dependent variable. Okay, there y is dependent variable, here v is independent variable. I don't have means we don't have any coefficient for dy by dx there. So here also we don't have any coefficient for this, we have to remove this. So that's what I'm whole dividing this equation by, or you can multiply the equation by 1 minus n. Okay, after that we got dv by dx plus p of 1 minus n of v is equal to q of 1 minus n. This is linear differential equation form and v is the dependent variable. Okay, and solve this by using the same method what we have done in the previous method. First we should find out the integral factor. After that we find out the general solution for that. Clear? So what we have to do? First we should divide the equation with a q coefficient. After dividing that, we have to take a p coefficient as v. Then you differentiate this. Okay, you differentiate this. Then you remove, means you can replace this first term by this what we have taken for v. Okay, then we got a standard linear form. Okay, after getting this equation we go for the solving, means finding the solution. As usual, first we should find out the integral factor, after that we find out the general solution. Clear? Okay, so first I am taking the example. Solve the equation dy by dx minus y by x is equal to y square. Okay, how can you find out whether it is a linear differential equation form or a Bernoulli's form? You see, in a linear differential form, the right hand side function is not in terms of y. Remember in your mind. Okay, it should be p. Here p is there, here q is there, where p and q are either it may be a function of x or it may be a constant, not in a y value, right? Okay, so then you can come to conclude that it is not a linear differential form. Okay, you can think that it is a Bernoulli's form. Okay, the whole equation is divided by y square. Okay, here y square is there now, q coefficient is y square. So divide the equation by y square. What I'll get? 1 by y square into dy by dx minus y by xy square. Y get cancelled, I'll get 1 by xy is equal to y square by y square is 1. Right? This first term as it is I am taking, this y I am taking to numerator, right? You will get y to the power of minus 1 by x is equal to 1. Then I am taking p and q are the functions of x. Here p value is 1 by x. So its coefficient is y to the power of minus 1. So that's what I am taking this as v. Y to the power of minus 1 as v. Okay, so you differentiate this minus 1 y to the power of minus 2 dy by dx is equal to dv by dx. In the next step, this y to the power of minus 2 can be written as 1 by y square dy by dx. I'm taking this negative to this side, it becomes minus dv by dx. Okay, see in the equation 1 we have 1 by y square into dy by dx. This can be replaced by minus dv by dx. Clear? Then this y to the power of minus 1, what we have taken for this v. Okay, so then equation 1 becomes minus dv by dx, okay, minus v by x is equal to 1. Clear? You see, 1 by y square dy by dx can be written as minus dv by dx. Here minus is there, minus y to the power of minus 1 is v by x is there, by x is equal to 1. But in a standard form, we don't have negative sign, right? For the first term. So that's what I am doing. The whole equation is dividing by minus. So I'll get dv by dx plus v by x is equal to 1. Now we can call this as linear form, linear differential equation, right? So we know the standard form dy by dx plus py is equal to q. Compare these two equations. Here v is a dependent variable. Here y is a dependent variable. Only thing is these two. Means v is here v is dependent, here y is dependent. Clear? The rest of the things are as it is. For this what we can do? First we find out the integral factor. So integral factor means we want p value and q value. Compare these two. What is p value? P is equal to 1 by x and q is equal to minus 1. Next we can find out the integral factor. Integral factor is equal to e to the power of p into dx, right? E to the power of p value is 1 over x dx, e to the power of log x. So e to the power of log of f of x is f of x only. So we can get integral factor is x only, right? So next we find out the solution. The solution is in the previous method what we can write y into. There y is a dependent variable, but here we have v is the independent variable, right? So that's what I'm taking v into integral factor is equal to integration of q into integral factor dx plus some integral constant, right? Y, what we got for integral factor, that is x is equal to integration of what is q? Q is minus 1 into integral factor is x dx plus some integral constant, right? Now you can integrate this here minus as it is. What is the integration of x? X square by 2 plus some integral constant, right? What is v? What we have taken the substitution for v? Y to the power of minus 1. Y to the power of minus 1 into x is equal to x square by 2 plus c. If I wanted to write in terms of y is equal to something, so y inverse is equal to, I am taking this x into right hand side, I'll get, means it comes to denominator, x square by x is x, right? And this is c by x. This is the solution for this equation. Clear? Got it? So what we did first we divide the whole equation by q coefficient. After dividing, we should take the p coefficient as v. Okay, then you can replace it and you can reduce to standard form. After reducing the standard form, you can write p and q value. After that, you should write the integral factor. After that, you can find out the general solution. Okay, the given equation first you reduce to linear form. After that, as usual, you find out the integral factor and the solution. Clear? Okay. Next, we go for the second problem. The second problem is x into dy by dx plus y is equal to y square log x. Here also the same thing. First we should divide the q coefficient, right? Here q coefficient is what? Y square. Y square we should divide, and in a standard formula we don't have any coefficient for dy by dx. So that's what the whole equation is dividing by this x and this y square. Okay. So what I'll get if I divide like that? So 1 by y square dy by dx plus 1 by xy is equal to log x by x. Okay. So in the next step, that 1 over y can be written as y to the power of minus 1, and I am calling this as equation 1. The same thing here, the p coefficient is y to the power of minus 1. I am taking this as v. To differentiate this, x to the power of n differentiation, right? Y to the power of minus 1 differentiation is minus 1, y to the power of minus 1 minus 1. Right? You will get y to the power of minus 2 dy by dx is equal to dv by dx. That y to the power of minus 2 can be written as 1 over y square dy by dx. I am taking this into minus this side, right? This 1 over y square into dy by dx can be written as minus dv by dx, and y to the power of minus 1 can be written as v. So the equation 1 becomes minus dv by dx plus v by x is equal to log x by x. Okay, I want to remove this negative sign. So the whole equation is multiplied by minus. I'll get dv by dx minus b by x is equal to minus log x by x. Now we can say that it is in a linear form, right? You compare this with a linear standard linear form, dy by dx plus py is equal to q. You write what is p and what is q. P is equal to minus 1 by x and q is equal to minus log x by x, right? So after writing these two values, you can find out the integral factor. Integral factor is equal to e to the power of integration of p into dx. P is what? Minus 1 by x. So I am taking this minus outside. So 1 over x integration is log x. So I wanted to uh, take this minus as a power. So means e to the power of a log b formula. So means sorry, a to the power of a log b formula. A log b can be written as log b to the power of a. By using that, this can be written as log of x to the power of minus 1. E to the power of log of f of x is f of x only. Here f of x value is x to the power of minus 1. So x to the power of minus 1 is nothing but 1 over x. Clear? Okay. So then we find out the general solution for this. V into integral factor, the same formula, q into integral factor into dx. V into the integral factor is 1 over x is equal to q is minus log x by x into 1 by x dx plus c. Okay, V into 1 over x. Here 1 over x into 1 over x is 1 by x square. Log minus log x into 1 over x square. I am taking this minus outside. One can be, here we have to apply the product rule for this. One can be treated as u and another can be treated as v. Okay, 1 over x square is v I am taking. Log x as taken as u because I don't know the value of integration of log x, right? So that's what I'm taking this as u. Yeah, we can do it by using the substitution integration of 1 into log x. There also you can apply the what product rule. There then we can find out the log x integration also. You may feel difficult for that. So that's what we go for a easy method. You can take this log x as u and this 1 over x square as v. So we know the formula, right? Integration by parts. So integration by parts is what? Integration of uv is equal to u into integration of v, right? In ಬರುತ್ತೆ. So u into integration of v means v dash, right? V dash, then minus integration of integration of wait a minute, integration of u1, right? U1, I'm just and v dash, right? So this u1 stands for the differentiation and v dash stands for the integration. Okay, log x I'm taking as it is. Log x taking as it is 1 over x integration means 1 over x square integration. So that 1 over x square can be taken as x to the power of minus 2, x to the power of minus 2 plus 1 minus 2 plus 1. Next is right minus 2 plus 1 minus 2 plus 1 what we will get? Minus 1 by x we will get. Minus is there here minus. Log x differentiation is 1 over x. So here minus we will get no here in the formula we have minus minus of minus becomes plus 1 over x. If you simplify this we will get minus 1 by x this. Okay, minus 1 by x. Here formula we have minus minus of minus plus and 1 by x. Log x differentiation is 1 by x plus some integral constant. Okay, in the next step log x, here you will get minus 1 by x, right? So log x by x minus integration of 1 by x square. So 1 by x square integration is minus 1 by x plus some integral constant. So you can multiply this negative side negative into negative sign into inside. So I'm cross multiplying this x to this side and v value is y to the power of minus 1. Okay, So in the next step, I am going to multiply this minus x inside. Minus of minus becomes plus. X get cancelled. You will get log x only. Minus of minus plus. X get cancelled. We will get 1 only. Okay. Then plus c. I think we will not get yes. One, wait a minute. So we will get one different bracket here. Sorry. Wait a minute. Okay. So now we will get the problem like means solution like this. Okay, this x is applicable for all the terms, right? All the terms. Okay, got it? So this is the solution for the second problem. Next, we move on to the third problem. The third problem is it is related to a trigonometric. Dy by dx plus y tan x is equal to y cube secant x. Clear? Here the q coefficient. Q is what? Function of x, either it may be a constant. This is secant x. Q coefficient is y to the power of 3. Divide the whole equation by y to the power of 3. There is no coefficient for dy by dx. That's what I'm not dividing any of things, right? Only y cube. Y cube is there. So that's what I'm dividing the whole equation by y cube. What I'll get 1 by y cube dy by dx tan x by y square is equal to secant x. Clear? Okay. So this y square, if I take to numerator, I'll get y to the power of minus 2. Okay. So we call this as equation 1. So p coefficient, here tan x coefficient is y to the power of minus 2. I'm taking this as v. Okay. Y to the power, then you differentiate this. Okay. I'll get this minus 2 y cube y to the power of minus 3 dy by dx is equal to dv by dx. 1 by y cube, right? This y to the power of minus 3 can be written as 1 by y cube dy by dx. I'm taking this minus 2 to this side, you will get minus 1 by 2. Okay, in place of this, in the equation we have this, right? Sorry, here we will get 3. Okay, in the equation we have 1 by y cube dy by dx. Okay, this can be replacing by minus 1 by 2 into dv by dx, and y square, this y square is replacing by v. Okay, then equation 1 becomes minus 1 by 2 dv by dx plus v into tan x is equal to secant x. Okay, I don't I don't want any coefficient for this dv by dx, because in a standard form we don't have any coefficient for that. So that's what I want to remove this. So the whole equation is multiplied by or divided by minus 1 by 2. Okay, what we will get dv by dx minus 2v tan x is equal to minus 2 secant x. This is a linear form. You can compare this. Then what is the value of p here? P is equal to minus 2 tan x and q is equal to minus 2 secant x. Right? Then as usual you find out the integral factor. So integral factor is equal to e to the power of integration of p into dx, e to the power of integration of, what is the value of p? P is what? Minus 2 tan x. Minus 2 tan x dx. Okay, minus 2 is a constant. Integration of tan x is log of secant x, right? Log of secant x, and by using the formula this can be written as log of secant x whole to the power of minus 2, right? So then our integral factor becomes secant x to the power of minus 2. So secant x to the power of minus 2 can be written as 1 by secant x whole square or secant square x. Okay, secant x whole square is nothing but secant square x. Okay. After finding the integral factor, we can find out the general solution for this. V into integral factor and integration of q into integral factor dx plus some integral constant. Clear? So then I'm substituting the integral factor value, and what is q? Q is minus 2 secant x. Okay. Then next we integrating this secant x and secant x get cancelled. Okay. Only we'll get 1 over secant x. So 1 over secant x is nothing but cos. These two are reciprocal functions, right? Okay. 1 over secant can be written as cos. Okay. So then minus 2 is the constant. Integration of cos x is sin x. Okay. Minus 2 sin x plus some integral constant. Okay. So y to the power of b, I am substituting the value. So v is y to the power of minus 2. Y to the power of minus 2. If you wanted to take the secant square x as this side, you can take it. So minus 2 sin x secant square x plus c into secant square x. Or else we can write this y square. The secant square 1 over secant square can be written as cos square x, right? Y square cos square x is equal to minus 2 sin x plus some integral constant. We can write anything. Anything is correct. This is also correct and this is also correct. Okay. This is the solution for the given problem, right? So I solved three problems. And I sent textbook also. Uh, you can do the problems related to this method from the textbook. And some students asked the good doubts regarding the previous problems, previous methods. So I sent solved means solved questions. So if you have any doubts, please ask me, and watch the video 1 or 2 times or 3 times. Understand the concept clearly. Then you start solving the problems. Okay, clear? This is Bernoulli's form. Equation reducible to linear form. Clear? Okay. Equation reducible to linear form. Clear? Only the thing is divide the equation by y to the power of means q coefficient. This is q is na ಇದ್ರ ಪಕ್ಕ ಏನಿರುತ್ತೋ ಅದರಿಂದ ಡಿವೈಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. That is q coefficient. Either it may be y square, yq, y to the power of 4, anything, y power. And suppose if you have any coefficient for dy by dx also, you can divide from that also. Okay. ಸೊ ಅವಾಗ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಇದರಿಂದನೂ ಏನು ಕೋಎಫಿಷಿಯಂಟ್ ಇರುತ್ತೋ ಅದರಿಂದನೂ ಡಿವೈಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಆ್ಯಂಡ್ ಕ್ಯೂ ಕೋಎಫಿಷಿಯಂಟಿಂದ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ after dividing the equation you will get some coefficient for p. Okay, p coefficient ಬರುತ್ತೆ. ದೆನ್ ಏನೇ ಬಂದ್ರೂ ಅದನ್ನ v ಅಂತ ತಗೋಬೇಕು. Okay, after taking that you can differentiate that. You can differentiate, then you can replace this, and after replace ಮಾಡಾದ್ಮೇಲೆ ನಿಮಗೆ then you will get one standard form, that is linear differential equation form. Then as usual you write a p value and q value. Then you can find out the integral factor. Okay, after finding the integral factor you find out the solution. Clear? Okay. I'm checking the wait Papu. Okay, clear? Okay. Okay, thank you. Thanks for listening. Stay home, stay safe. Thank you.